In this video, we are going to look at simultaneous equations and we are going to look at some examples. To solve simultaneous equations, we have about 3 methods that we can use. You could use what we call substitution, you could use what we call elimination, or you could use the graphs, meaning you would draw your graph and then you use your graph to find the solutions without solving them. Now we are going to look at one example and then we are going to use elimination and substitution to solve this. Okay, in this example we are going to be looking at what we call elimination to solve our simultaneous equations. Now the question will say solve this equation simultaneously, or it could say find the solution or find the values of x and y. Or it could say find the solutions to the 2 equations. Basically, that just means the same thing. Now, in this example, I chose this and I wanted us to look at elimination. Remember we said we have 3 methods to solve simultaneous equations. We could use what we call substitution, or we could use what we call elimination. Now, perhaps we could also use our graphs, but that's not quite always necessary for you to draw your graph and then find the solution. So we are going to, you choose the method that fits the question. Now, it's better to know both, because then you will study your equations and then see which method is much easier to use for you. Now, like this one, I see that all the coefficients are quite big numbers, not quite big, but are numbers. There is none that is just 1. If there was one that is 1, I would just want to just substitute, because then I can make that variable a subject of the formula. However, since I see that the coefficients are, none of them is 1, then it means it's easier to use elimination. But that's just personal preference. Now, the first thing you want to do when you are eliminating is you want to check your coefficients for the same variable. Coefficients of y, coefficients of x. Now, look at the coefficients of y. Are they the same? They are not. Coefficients of x, are they the same? No. Hence, you need to make sure you try to make one of the variables to have the same coefficient, exactly the same number. So if I have 5x here, I want to have 5x here for me to be able to eliminate it. Remember, elimination means I'm getting rid of something. So for me to get rid of it, it must be the same. So that's what I'm going to try to do. I'm going to try and change these equations. So I'm going to choose a pair of the coefficients of one variable. I could choose the ones for y, I could choose the ones for x. So let's say we want to choose that just because it's the first one. So we choose that, then we are going to use those coefficients to multiply our equations, meaning we are going to, this first equation, we are going to multiply it with the coefficient from the second equation, and the second equation we are going to multiply it with the coefficient from the first. So basically what we are going to do is we are going to do that, then we multiply the first equation with 4 and the second equation with 5. So now, if I multiply 4 by 5, I get 20x. 4 by 7y gives me 28y, so that is positive 28y, equals to 4 times 11 gives me 44. So that is now my new first equation. Now, if that is now my first equation, now I need to continue to the second equation. I'm going to say 5 times 4x gives me 20x. 5 times 3y gives me 15y, and 5 times 14 gives me 70. Now this is my new first equation and my new second equation. However, let's not forget that it's the same. It's just that we are writing in a way that makes it possible for us to eliminate. Now that the goal was to make one of the variable get the same coefficient, and I can see that now after my multiplication I got that x have the same coefficient. Now that means I can actually eliminate it. Now I need to ask myself, now so what I'm going to do is I'm going to draw this line. I'm just drawing it so that I can get my solution, because I'm working with like terms. So I'm basically going to work with these, work with that, put my equal sign, continue with that. Now, I see that there's a 20x here and a 20x here. Now I need to ask myself, for me to eliminate that 20x, what sign should I put between them so that they can take each other away, so that it can become 0? That's basically what I'm asking myself. So what I'm going to do is I can see they are all positive, so I should understand that if they are all positive, or basically if they are all negative, what I'm going to do is I'm just going to subtract. So every time I see that they have the same signs, what have the same signs? The variable, the term that I want to eliminate, if it has the same sign, I always subtract. Or they have the same signs, I always subtract. However, if they have different signs, I'm always going to be multiply. That means it's positive or negative and positive. Here, I'm going to always add. So we are going to apply the next part in the next example, but for now, let's just continue. So basically what I'm going to do is I'm going to subtract because I see they're all positive, so they're all having the same sign. Remember, I'm saying that I'm looking at the one I want, the term I want to eliminate, and because they are all positive, I'm going to subtract. So I'm going to do that. So I'm going to say, what is 20x minus 20x? That's 0, so it's gone. So it actually goes because it's eliminated when I subtract. However, I decided to subtract because I wanted to eliminate that. But I always do the same thing, the same methodology when I go to the next terms. If I decided to subtract here, I should subtract there, subtract there. So that sign that I decided on to eliminate that should apply to everything. So I'm going to say, what is 28 minus 15y? So it's 28y minus 15y, and that gives me 13y. And then I continue. Remember, I must apply the same sign. I must apply the same subtraction that I decided to use here. I'm going to apply it to the next terms and the next term. So the equal sign, I just copy it down. Then I'm going to say, what is 44 minus 70? That will give me negative 26. So I can see that, okay, now x is eliminated, and that's why we call it elimination. So now I can actually, now that I have one unknown, I can actually divide by 13 to get rid of this 13. Divide by the 13, so that if I say 13 divided by 13, I get 1y, which we just write as y, and then I'll say, okay, that is equal to, and I say negative 26 divided by 13, that is going to give me a negative 2, and that I'm going to say, okay, that means y is actually negative 2. So I got my solution to y. Remember, I can't just end there. I need to find the solution to x as well. So I need to go back. Now that I know what y is, that y is negative 2, I need to go back to my equations and choose which one is much easier to use. I'm going to choose any one. Let's say we choose the second one. So basically what we're going to have is that we choose the second original equation equal to 14. Then I'm going now to replace y in this equation. Now that I know what y is, I'm going to substitute in this equation. I'm going to put, wherever I see y, I'm going to put negative 2. So I'm going to say this is 4x plus 3. Then I put negative 2. Then I say equal to 14. I solve this. I'm going to have 4x minus 6, because 3 times positive 3 times negative 2 is negative 6, equal to 14. Then I know that I need to take this over so that it can go and join its brother here. It's like term. So I'm going to add 6. The reason I add is because when you say negative 6 plus 6 gives me 0. And that means it's going to go because it gives me 0. So I'm going to say I'm left with 4x equal to, then I have 14 plus 6, and that surely gives you 20. So if it gives me 20, I'm not done. I must still get rid of that 4 that is next to x. So I need to get rid of this 4 because I just want x. So I'm going to continue, and I'm going to divide this by 4. Divide it by 4. Why? Because I need the 4 to go. Because I know if I say 4 divided by 4, I get 1x, which is just x. Then I say 20 divided by 4, which gives me 5. That concludes my solution to these equations. And I can see that, okay, basically what I have is that these two equations, for those two equations, y is going to have to be negative 2 and x is going to be positive 5. That's the solution to your two equations. Okay, moving on to the next set of equations. So we have our new equations, and this is our equation 1, and this is our equation 2, and this time we are basically solving, or we are actually solving for A as well as for B. So what matters is that we are solving our equation, or we are finding our solutions to the two equations. Now we are still going to first use elimination, and then we are going to try this using, because if we knew all methods, we would use substitution. It would also be easier because we see that one of our coefficients of A here is 1. So basically we can make A the subject of a formula, and then we substitute in the second. But we are not going to look at substitution now. We are going to continue with elimination. Now let's not forget that there's an invisible one that is there. It's not written there, but we should not forget that it's there. So what I'm basically going to do to eliminate again, I still see that there's no variable that has the same coefficient, meaning this is 3b, this is 2b, not the same. This is 2a, this is 1a, not the same. I want them to be the same, one of them to be the same for me to be able to eliminate. So I'm going to choose my coefficients again. So I'm going to use this one. Then I'm going to say, now let me say we decide this time to choose the coefficients of the next term. So we are going to choose this one. Now some people prefer to take it with the signs. Myself, I prefer not taking it with the signs, just because I want to just keep the negative there, just to make sure that my learners don't get confused. However, it still works fine when you take with the signs with. So basically that means I chose 3 and 2, so my brackets down, and I'm going to multiply these first one, since I'm choosing this. So I'm going to multiply the first equation with 2 and the second equation with 3. So basically my new equations, or set of equations, will be 2 times 2a, which gives me 4a, and 2 times negative 3b, which gives me negative 6b, and 2 times 16, which gives me 32. So I write it down. Then I go to the next one. 3 times 1, that gives me 3a, and 3 times positive 2, that gives me positive 6b. Let me not forget the variables. And then I'm going to say, now what is 15 times 3? And that gives me 45. So now I have my new set of equations here, and I'm gonna solve these. Now I can see now there's 6b. So I just need to decide on what sign should I use to eliminate, and that's the reason that I don't take the signs with. Sometimes if you have taken the signs with, then you will see that it's gonna be the same, so you're basically going to just eliminate them straight away. However, I haven't taken the signs with, so I'm gonna check what is the sign in front of the term that I wish to eliminate. I can see that there are different signs. So now that there are different signs, remember we said if there are different signs, always just going to add. So basically I'm going to add the term, so that, and remember to confirm that I have indeed used the right term, just say, what is negative 6 plus a positive 6, or just negative 6 plus 6? That's basically the same thing as saying 6 minus 6, so it's gone. You can always use your calculator to confirm that. Once you know that it's gone, it actually tells you that I have eliminated it because it's gone. And once that is eliminated, it means I have used the right sign. So I'm going to use the same sign there then. So I'm going to say, what is 4a plus 3a? That gives me a 7a. Remember, this term is gone because it gives me 0. So it's gone. Then I'm going to say, now, what is 32 plus 45? That gives me a 77. Remember, the goal was to eliminate. So if I say 32 plus 45 gives me 77. Now basically what I have is I have 7a is equal to 77. So basically I can get rid of this 7, because I know once I have a product, to get rid of what I don't want, I'm going to divide, because when I divide, it gives me 1a, which is basically just a. But let me not forget that whatever I decided to do this side, I should do this side. So I'm going to say 77 divided by 7, and that gives me 11, and therefore I have found my A. I'm going to go back and choose one of the equations. Remember, let me not forget to put my line there. This line, I just put it there just to know that I'm working on the like terms, because I'm basically, these I get by finding the solution to these two. So let's not forget that. Then I go back to my equation. So I'm going to choose the equation. I'm going to substitute now. because I'm now going to go back and try to find my value of b now that I know what a is. So I'm going to go back and choose either of the equations. Let me say I decide to choose this first one. That's perfectly fine, whichever one you're comfortable with. So I'm going to say this is 2 times 11 because now I know what a is. The rest don't change. Then I continue. That is going to be 22 minus 3b equals to 16. I want to take the 22 away. And because it's positive 22, I need to minus 22 so that it can become 0. But whatever I decided to do there, I should come and do here. So basically, I'm going to say, okay, this one is now gone. So I'm just basically left with negative 3b. Then what is 16 minus 22? 16 minus 22 gives me a negative 6. And I want to get b, not negative 3b. So I need to get rid of the negative 3. Then I know if I say negative 3 divided by negative 3, it's going to give me 1. But whatever I've decided to do that side of the equal sign, I should do on the other side of the equal sign too. So I'm left with b equal to, and a negative 6 divided by negative 3, that gives me a positive 2. Then that means I am done. Okay, now in this last example, I'm going to use the same set of equations that I used in the previous examples, just to kind of explain to you what I would do in case I was basically asked to use substitution and I had these 2 equations. Let's say I knew both methods, and I knew substitution and I know elimination, and that's what I would advise you to do. What you're going to do is you try to find which method fits here. For example, in this set of equations, the coefficient of a is 1. So basically, I can actually use substitution because then I know I'm just going to take my second equation. So remember, this is your first equation, second equation. So I'm going to take my second equation, which was that equal to 15, and then I'm going to make a the subject of a formula. Remember, making a the subject of a formula just means you are solving for a. So basically what I'm going to do is take away what I don't need. So I'm going to, since it's positive, I'm going to say minus 2b. Then I take it to the other side. So basically what I'm going to have this side is minus 2b, and this side, this is going to go because it gives me 0. Therefore I can see now a is 15 minus 2b. Now that I know what a is, remember I don't know the value, but I do know the equation or the formula or the expression that gives me the value of a. So I'm going to go back and this, remember, is still my second equation. So I'm going to go back and then go back to the other equation, which was this. Then everywhere I see a, I'm going to put these because I can see that they told me if something is saying a is equal to that thing, then it means I can use that thing instead of a. So basically what I'm going to do is I'm going to come to my next equation and substitute a with 15 minus 2b. So basically if I do that substitution, I'm going to have 2, then I put my new a, which is that. Then I will close it because that's a. 2a minus 3b equals 16. All I did there was come now after having a as a subject of a formula, came to the other equation, then I do my substitution, meaning I'm going to replace a with the expression I got that gives me the value of a. So now I'm going to remove my brackets and just solve this the normal way we solve our linear equations. So I'm going to say 2 times 15, that gives me 30. 2 times negative 2b, that gives me negative 4b minus 3b equals 16. Then I can see now that these two are like terms, these are like terms. So basically I'm going to say this negative 4b minus 3b is going to give me a total of negative 7b. Then I'm going to say that is equal to, but I need to take away the 30 to its brother this side, so it must go back, it must go to its family. So I'm going to say 30 minus 30, then I will say 16 minus 30. So basically the reason I'm doing that is because I want to make sure that I at least group my like terms. So I'm going to have 16 minus 30 will give me a negative 14. Then from this side it's gone, it's now there. So that means I have a negative 7b equal to a negative 14. Now I need to get rid of the 7b because I don't need it. I want b. I was not asked to find negative 7b and b. So I need to get rid of this one that I don't need. Get rid of the trash. So I take it to the other side. Then I'm gonna see that this goes because negative 7 divided by itself is just 1. So I'm left with b equal to, and a negative 14 divided by negative 7 gives me a positive 2. So that basically tells me that, okay, now if I get a positive 2, that tells me that now that I know what b is, I can go back. Remember, therefore, I'm going to say a is equal to 15 minus 2 times the b I got, which is going to be 15 minus 2 times 2, which means I have 15 minus 4, and that gives me 11. That implies that a is 11. So I have my two answers, b there, a there. So that's what we call substitution.